Okay, unmute. All right, can you hear me coming through on your speaker?
Yeah, we can hear you now.
Yeah. Awesome. So I'm Derek Ross. I'm the field CTO. Erik's the CTO. All that means is I'm the customer facing person. So really, I'm a solutions architect. I used to be a solutions architect at AWS. Since we don't have that many people here in the room, if we go around, introduce yourself, let us know what you do and where you work at. So go ahead and start with you, Brett.
Yeah, so I'm Brad. I'm one of the organizers of Salt Lake City DevOps Days. And just one of the organizers here.
I'm gonna need that. I'm gonna need that in a minute. Okay.
So let's
Erik,
go.
you wanna?
Oh, Erik Jensen, CTO TrueMark.
Oh, okay. My name's Colin Lentz. I work at Dell and the site reliability engineer. So
Nice to meet you.
I'm John Forsyth. I'm a professor and teacher at Python.
Cool.
No, I'm a principal engineer at Best Notes up in Idaho and a long drive today. That is a long drive.
Did you drive down for us? Yeah.
Erik and I also work for TrueMark and also formerly the board of DevOps Days. Joe Fish, Vice President of Customer Success at TrueMark.
Gina, marketing at TrueMark.
Randall, Director of Operations for Company Systems, organizer of SLC DevOps Days.
Cool.
Adam Fairbanks, CIO at Nexio.
My name is Brody Sabresos. I'm the IT director here at MTech, and I was initially just here to help them get set up in the room, but I'm interested in the presentations.
Cool. A couple questions for the room. So one, has anybody built an application on generative AI, whether it's on OpenAI, Azure, anything? Have you built anything? Okay, we got.
Just small, like chat bot type stuff.
Have you interacted with the API at all? With any API, sending system prompts or human prompts, anything? Nope. Okay. Oh, to OpenAI. Okay. So today we're going to talk about specifically the models that AWS has to offer and what the paradigm is with AWS. I apologize. I fried my slides prior to this meeting. So I wanted to give you a little intro into the different pieces, puzzle pieces that you'll be interacting with when building a generative AI application. I'm just going to whiteboard it out so we can talk about it. If you have any questions or you want me to explain something a little deeper, Erik and I can talk about those different subjects. So Amazon Bedrock is fully managed model hosting on AWS. So if you've ever used something like a serverless application on Amazon, or if you've used like OpenSearch serverless, Amazon just handles everything under the hood for you. And it exposes models that you can use. And I'll show you that UI here in a moment. What's cool about that is you get model variety. So when you go to OpenAI or you go to Anthropic and you sign up for a subscription or you put credits in to use OpenAI's API, you get their models and that's all you get. With Bedrock, you get Amazon's models. They've got Titan models. They've got Anthropic models, Cohere. There's a few that I'll show you how you can turn those on and select from them. So you get a variety of models. And in your application, you can use multiple models or you can select or you can change models as you go as they release new models. You get customization. So there's a framework built into Bedrock that allows you to use agents, allows you to do some fine tuning of existing models. There's a new feature that I haven't got to play with yet. It just got released during reInvent, but you can import models and expose those and they'll host them for you. And then you get integration into AWS services through the different ways that they bubble those up, whether it's through knowledge bases, which I'll talk about here in a minute, and we'll get deeper into in the demo that we do. But you can integrate with IAM, which is identity and access management. You can interact with object storage using S3, and then you get access to something like a vector database using pgvector or OpenSearch. And then the best part about it, or it really drives enterprise and higher education towards using something like Bedrock, is isolation. So if you've ever used something in Azure or used something in AWS like relational databases, you know that you don't get to see any of the infrastructure under the hood. You don't get to interact with the server, really. You get to see maybe the OS layer. But what you do trust is that's isolated into your account. So if you put HIPAA data into a database in your AWS account, you believe and know that that data is isolated and that you can do a HIPAA classified application on top of that database. You can do the same thing with Bedrock. So these models are isolated. It's an instance of the model that's being exposed to your account through the SDK or the API, however you're interacting with it. And all of the data that you feed to it isn't being used to train Anthropic's models, isn't being used to train Llama's models. So I lost some of my slides, so I'm going to talk about a few different layers that we're going to work with today. So first thing I'm going to talk about is knowledge bases. First, I'll talk about RAG. So I mentioned RAG up here. RAG is Retrieval-Augmented Generation. Has anybody worked with RAG before or messed with a RAG source? All right. So when you go into ChatGPT and you ask a question of the model, you might ask, what is TrueMark? And when you ask what is TrueMark, there's another financial company out there that's TrueMark that has better search engine optimization than our website. And you're going to get an answer about that financial company. So what I can do is if I have a model, and let's just say I have Claude's model. What I can do is I can connect a knowledge base. And we're going to get deeper into that. And that knowledge base will be connected to an S3 bucket. And inside that S3 bucket, I will have a folder called /docs or whatever folder structure. And in there, I will have TrueMark.pdf. So now when I feed this a prompt, it goes back to this RAG source, this Retrieval-Augmented Generation. This is indexed, this TrueMark PDF. It finds the information about TrueMark. And when I get my return prompt from Claude V2, it's going to give me information that's more specific to TrueMark because now it has another source of information to feed me that information. It does that through vector databases. There are multiple types of vector databases that you're going to hear about. On Amazon, you've got OpenSearch. You've got PG Vector. And you've got Kendra. Kendra is historically an enterprise search function. It's got a lot of different connectors. You can connect it to SharePoint. You can connect it to S3. You can connect it to Office 365. You can connect it to Slack. You can connect it to GitHub. It will index a bunch of your data from there. PG Vector is Postgres. It's a plugin for Postgres databases that will support vector databases. And then OpenSearch allows you to create vectorizations within OpenSearch servlets. So in these setups, you can use AWS native service. You can also use third-party services like something like Pinecone. And you can integrate that into your application. What this does is it takes all of the unstructured data in that PDF and it creates a mathematical representation so that that database can be searched and all that information can be provided up to the model. So you are familiar with Claude, you're familiar with ChatGPT's like the 40 model, but you need something in between to actually talk to this. So that's where you get embedding models. So embedding model acts like a traffic cop or a librarian. So when you go to the library and you're looking for a book, you might not necessarily know how the index system works in the library. You don't know what section has nonfiction or what section has fiction. So the embedding model acts as that index to go through and search the vector database to provide the LLM the information that it's looking for. So you've got the LLM, the main model that we're going to be interacting with, the embedding model. This is going to be important when you're selecting how you interact with your RAG sources as you set up your application. You've got your retrieval-augmented generation and where you actually store your unstructured data. You can also interact with structured data, but that gets into some nuances, and we'll get deeper into that as we get into the demo. You're also going to want to think about how you set up prompts. So the last thing I'll talk about before we start getting into some code examples is prompt engineering. So in your setup for the model, before you start feeding things into Claude, you can let it know certain things. So if you're setting up a code advisor that you want to present to your employees, you may say, act as an AWS engineer. Your next one may be return all responses in TypeScript. And you may say, stick to my company's style guide. All of these happen under the hood, and they're known as system prompts. So you've got system prompts, and then you've got the human prompts that are actually coming from the user, and that's what you're actually typing into the chat to interact with the LLM. So this is just a primer to kind of let you know some of these Lego pieces that you're going to be thinking about when you're building your application. What questions do you have about any of these pieces? Do you have any questions? Which one?
SS.
S3.
Oh, sorry, that's S3. That's simple. That's a simple storage service on Amazon. That's just one place you can store objects. When Erik pops up, he's going to show you all of this in code, but I wanted to give you a little flow on what Bedrock is. So this is the Bedrock console in AWS. Who's logged into AWS before? Cool. All right, so when you go into the console, you go into your account, you can see here I'm in my account. If you search for Bedrock, it'll take you to this Amazon Bedrock service. If you start going down the AI road within Amazon, you've got 3 different services you're going to hear about. You're going to hear about Amazon Q. Amazon Q is like the super easy button, super opinionated. You have no control over the model. You have very little control over how the connectors work, but it gets you up and running in minutes, and you can kind of start playing with stuff. You can upload some PDFs, and go play with it. But it is completely laid out for you, and you have very little control over it. The next layer down is Amazon Bedrock. That's going to be what we talk about today. You can think about this as a box of Legos. So you've got an instruction set. You kind of know what the output's going to look like. If you follow it step by step, you can build an application, and everything is already pre-built for you in these pre-existing blocks. Then you've got Amazon SageMaker. So if you search for SageMaker, I'm not going to go deep into that today. SageMaker is a whole nother platform, and it's been around for a long time. This is where you can get into traditional AI ML model building. So you get access to the base algorithms. So you can use Jumpstart to get access to some of these models. You can get access to LLMs like Llama 7DB, or you can get access to more traditional machine learning models and start working with those. There's CI/CD for AI ML ops built into that. You've got single button deploys, so you can deploy some of these models to specific infrastructure that's built for that, but it can get really pricey. So the middle road that we're going to talk about today is Bedrock. And in Bedrock, you can go down here in your lower left-hand corner, and you can select model access. If you want to play with this and start interacting with other models, and you have an AWS account, you go down to model access, and then you're going to enable all models. You'll go in, you'll click next, and that's going to request access for all these models. You hit submit. And now you can actually start interacting with these models. You'll see that that access was granted. If I want to go and play with Claude V 3.5 Sonnet, I can go to the chat playground. In that chat playground, I can select the model, go to Anthropic, 3.5 Sonnet, apply. You can play around with the temperature and some of the other configurations. I'm going to ask it to build a cloud formation template. And you can see it spit out a little bit of code for me. So this is a great way to start playing. One of the things I mentioned was knowledge bases. So here's where you can set up your knowledge bases. We're going to do a lot of this in code. You have the ability to create agents. So agents allow you to select which RAG source that you want to interact with. You can set up actions based on what's going on in these agents. You can get really complex with these. You can set up multiple agents in an application and decide which agent you talk to based on the user session that you're in or who's actually interacting with it. But that's your high-level overview of what Bedrock is, what AI is on AWS. So now we've got a code example called Ask Bob. All the code that you're going to see today that Eric's going to present is available on GitHub. So it's all open sourced. If you want to download it on your machine, you want to deploy this into an AWS account, you can. There are some cost ramifications with that we'll talk about as we go through it. So you're going to want to make sure you tear it down if you do end up playing with it. But I'm going to go ahead and bring Erik up, and he's going to go through Ask Bob with us. Yeah. And if you've got any questions, feel free to stop us as we're going. There's not a ton of us in the room. So if you want to dive deeper into any section of code, go ahead and just ask. I was about to say, do you want to take a second to let everybody get their food?
Yeah, let's go grab some food.
Yeah, go ahead and go grab some food.
Yeah. My entire
Hey guys, we have no audio on the Zoom session.
All right, let's get this started. I'm gonna show you some code. And let's start with these and this. Okay.
I don't know if you want to do a round of reintroductions.
I'll just introduce myself and we'll get going. Okay, I am going to show you code because that's what I like doing. So before we get going, we're going to actually start with two things. So I'm going to show you some really basic examples. So that's easy mode on how you can write code and talk to Bedrock. And then I'm going to show you hard mode, which is, this is the Ask Bob application. You guys can actually navigate there and chat with it. Just be aware, it's a GraphQL API using subscriptions. Whatever you post there, anyone else that's viewing it can also see. So it gets fun. Yeah, can you guys hear me all right? Okay, and can you guys see all right? Okay, and let me know if you can't see the code. So we're going to start with the basic examples. I know a couple of you guys have seen these already, but we're going to walk you through this. So first. These are in my personal GitHub repo. Example, AWS Bedrock Basic. I haven't updated this for a little while, but these are where I've got like, the 101 Bedrock examples. This is what we're going to go through first, and then I'm going to show you Ask Bob, which is in a separate repo that's owned by TrueMark. So first of all, there are a series of examples in here. All you need to be able to run these examples, just have Node installed, PNPM, which is a package manager, and you just have to have a model enabled in Bedrock. So I've got the Claude 3.5 v2 Sonnet enabled that we're going to be using. So I'm going to walk you through some basic code with Bedrock. And we're going to start with the invoke model. So this is all TypeScript code. We're using AWS's SDK. So this is their software development kit, and we're using a client called the Client Bedrock Runtime. So there's also a client Bedrock. That's what you would use to go orchestrate in like infrastructure with Bedrock. The runtime clients are meant for you to interface as an application with your Bedrock models. So inside of this example, we have what's called invoke model command. So Bedrock does not hide the details of the large language model that you're using underneath. If you guys want to make direct calls to like Claude and you want to be able to pass very Claude specific things that Anthropic has built into their model, you can do it using this command, but you have to understand each model. And if you were to go change models and say, instead of talking to the Anthropic model of Claude, I wanted to talk to the meta model of Llama, this wouldn't work. I'd actually have to go modify my code to be able to go talk to Llama. So there's no abstraction with the invoke model command. This is like the base level. And then all we're doing is we're just passing it a message. We tell it the maximum tokens. That's very dependent on your large language model. There's an Anthropic version we have to pass. And let me show you this working. Grab my creds real quick. I will also tell you, if you guys are going to play with this, use US West 2. The newest models seem to get released in Oregon before any of the others. So at the time I wrote this, this was actually the only region that actually had this model. So we're just going to run a pnpm run command with the name of this, and then you will see it generate a response. I have to set my region. Yep. There we go. So you should see a response here. Assuming the internet's okay. So I asked it, how tall is Mount Timpanogos in Utah? It generated a response. So pretty basic, shows you how to interface with it. It's not very much code. This is how I'm printing out the response. So what is that? That's less than 50 lines of code. And all I had to do was enable the model in Bedrock. That was it. So super basic. I'm now talking to a model. I didn't have to actually set up any infrastructure other than just enabling the model. So let me show you the next example. So the one very nice thing that Bedrock brings is abstraction. So AWS has provided a command called converse command that lets you talk with any of the models that are in Bedrock without having to know the model specifics when you're communicating with it. So I could take this Anthropic model and simply replace it with a Llama model, and I could actually run the code and ask it the exact same question. So you can see this working. So I asked it the same question, so it should give me the same result. Or, oh, I asked it a different question. Asked it a different question. Anyway, give me a result. This is using the converse command abstraction. Same thing. I'm getting the response, printing it out. And again, it's actually short the last one. So then you have converse stream. So this is the same example that you saw before, although I'm asking it a different question. And I'm going to stream the response. So this is the behavior that you would see or that you get when you're talking to like ChatGPT, where it's giving you the answer as it's coming up with it. And then, so there you go, streaming the response out. And this is how you stream responses. So you essentially just do a for loop over a response stream. And then when there's nothing left, it bails out of the loop, off you go. So pretty basic. So we are now going to show you how to do prompts. So with large language models, you have the ability with nearly all models in Bedrock, you can pass system prompts. System prompts are you as a software engineer essentially telling the model how you want it to behave. So when you have a user interact with a model, it's taking those suggestions and then behaving that way. So I said, hey, I want all my examples in TypeScript. Hey, I want you to use the V3 SDK, which is the latest JavaScript SDK from AWS. And if you're going to end up using a region, I want you to give me the code with US East 2. So these are system prompts. I, as an engineer, have put those in. If anyone goes and asks this a question, it should work within those boundaries. And the question I'm asking is, how do I list S3 buckets? So what I'm expecting is actually an answer in TypeScript, not some instructions on how to do this in the console. So let me show you how that works. And same thing, we're just streaming the response out. So there is my code. It even shows me how to run it. So there's the block of code. You can see that it's in fact using the V3 API, and it is actually using US East 2. If you want to know that that prompt's working, I'll actually comment this guy out. And if I run that again, now I'm getting US East 1. And then if I want to do something crazy, I'm going to ask it how to do this in Go, because it's another one of my favorite languages. So that's how you do the exact same thing with Go, right? So I'm interacting with Claude and I'm passing system prompts, streaming the result, pretty basic, no infrastructure required. So that's that piece. And let me show you the next one, which is how we do conversations. So there's better ways to do conversations. The idea in this example is to express how it works, so you guys kind of know what's going underneath the hood when you're using something like AWS's agent, or you're using LangGraph, or something else that's orchestrating that agent. So I am going to show you this example. We're going to walk through this. So I instantiate a runtime client, and then these are the system prompts. It's the exact same system prompts that I was using in the last example. And then I have a messages array, and I'll explain this here in a minute. The first thing is I'm going to pass in the question that I have, which is how do I list S3 buckets? Okay, pass it into the messages array, and then I execute it. So I'm calling that converse stream command. I'm passing in the message, or actually the messages array that has one message in it. I'm passing in my system prompts, and I'm going to get that response back that you guys saw in the last example. So stream that out. And then what I'm doing is I'm taking the response that Claude gave me, and I'm actually appending it to the array. And then I'm going to ask it another question. You'll see that's what assistant is. So with Bedrock, if you are passing a message and you say that the role is assistant, it knows that that was an answer that it previously gave. That's how it's maintaining context. Okay, so it's using that as an input. And then I'm going to go ask it, hey, can you add pagination to the previous example? Right? So it should have the answer to the previous example and then go add pagination to it. So it's the idea of how to carry on a very basic conversation with some context history. So this does break down at a certain point. You're only, I believe it was a 5 or 6 megabyte payload that you can get to when you're sending stuff to Bedrock. The way around this is you use knowledge bases and RAG sources. So you can actually use a RAG source as essentially a way to store state if you guys want long running state. Also with AWS's agent feature, it'll maintain like 30 days of session history. So you've got some flexibility, but it's really important, I think, for people to kind of know what's kind of going on under the hood and what options you guys have. So this is a way to add context. So, okay, let me go run this guy. I'll show you it working. So there's my example. And then there's my, yep, and there's my, let's see here. Oh, add support. Yep, so there's the continuation token. So I actually asked it 3 different things, just so you know. So there was the continuation token question. So I asked it to give me an example, asked it to add pagination, and yeah, that's what we got. It's quite a bit of content that it's streaming out. So it's actually a pretty good example, and this code is actually pretty dead on. So one of the really cool things with this is if I was working and I wanted to go play around with a bunch of different models, it's super easy for me to go and simply change that model ID, and now I'm going and messing with Llama, right? Or if you want to mess with Titan, which is AWS's, or you want to mess with one of the Cohere models, you can do some experimentation with code really rapidly, really easily, and you don't have to stand up any of the large language models yourself. So pretty cool. I actually recommend you guys go clone this repo down, run the examples. You guys can go putz with it. It's really easy to, and it like Derek showed you guys how to enable those models in your accounts. And when you're doing stuff like this, like the cost is super nominal, so there's not much to it. So before we go into hard mode, do you guys have questions about kind of the simple mode stuff, talking to Bedrock? Yeah. Yeah, yes, sort of. So prompt engineering is interesting. So this is what's going on under the hood. If you end up using, you can always do prompts this way, and you can do prompts this way with agents. There's also prompts within Bedrock where you can pre-configure prompts, play with them, and attach them to the agents as you go through and orchestrate. So yes, so prompt engineering is a little more in depth than just this, but this is like the basics. So conceptually, yes. Any other questions? So the answer is yes. Let me ask that or answer that in a, I'll try not to complicate this. So what ends up happening is when you're passing that messages array to your large language model, it's consuming tokens as it digests that information. So it's not like you pass tokens in, it's actually tokenizing the data that you're passing as inputs. And you have a lot of flexibility with these models in how that data gets tokenized. So in the screenshot that Derek showed when he was showing you the Bedrock UI, you have like temperature controls and things like that. That's a lot of the flexibility that you have to control how that data gets parsed by the LLM. Now, the other piece of that is with a RAG model, what you're doing is you're taking data, you're going to use an embedding model, so not a foundational large language model, but an embedding model that's specifically trained on how to vectorize certain kinds of data that's specific to like the domain you're working in, right? Or the data set you've got. And then it's gonna, when you pass that data to the embedding model, it takes that, vectorizes it based off parameters you have, and then it'll shove it into your vector database. So that would be OpenSearch serverless, Pinecone, pgvector, there's a bunch of them. And then what happens is you can attach that essentially to your large language model, and you can use it as a data source. And the way it works is if I go and ask the large language model a question, I'm passing data inputs to it. If I want to pass information that was previously vectorized in a RAG source, what I actually do is I go and ask the embedding model to go and get me data, essentially produce a query for the vector database based off what the criteria that I'm searching for. So I could actually give it the question that I've asked, and it will go and produce a query for me that then I can go take and I can go apply to that vector database to get data that I then pass to the large language model. Bedrock actually abstracts a lot of that for you. If you were to code it manually, that's exactly what you'd be doing. You'd talk to your embedding model, you would get your query for the vector database, you'd query the vector database, pass that data into the large language model, basically. So behind the scenes, when you use knowledge bases in Bedrock, all of that's abstracted for you. You essentially are providing it the data, you choose your embedding model, you fine tune your embedding model, and then you connect that knowledge base, which has your data source, could actually have more than one data source, your embedding model, and you attach it to essentially an agent. And then when you ask that agent questions, it uses that as a RAG source. So that's how you get tokens essentially made available to your large language model. Outside of that, you can always train a model, right? To try to get that information embedded in its core model. So the recommendations generally always try RAG first. And then once you nail that out, if the data's pretty static and it's not changing frequently, training might make sense, right? If it's data that you always need and you're not gonna have to retrain frequently, that would be the place to go after that. But a lot of times RAG will get you where you need to go, and then you don't need to go any further. It just depends. Does that answer your question? Hopefully that wasn't too complicated. Okay. Any other questions before we look at the Ask Bob example?
I've got questions on Bedrock in general, but we can wait until the end.
Okay. All right. So let's do hard mode. So let me show you Ask Bob working. We'll see if anyone put anything horrible in here. Nope. Everyone was gentle. So internet's a little slow here. So I'm just going to ask it a question. If you guys actually had this, you guys would actually see Brittany posting a question. And if you guys connect to it, it'll just give you a random name. Yeah, there you go. So you got Anthony asking a question. Should not, just so you know. So there's a little bit of latency, and then it's essentially providing the answers there. We'll see if that one does it. It's acting a little slow. It probably, there you go. Ha, eat it. Perfect. I actually wasn't sure I was going to answer that one. I'll show you why. We have some constraints in this model. So anyway, yeah, so you are actually interfacing with Claude, and it's attached to two data sources. One has indexed our website, and the other one has indexed a PDF, and I can't remember what was in the PDF, Derek. Do you remember what there was in the PDF we dropped in there?
I think it was 2019 TypeScript. Standard.
Okay, so you could ask a TypeScript questions out of the standard, it's just no. Yeah. So in any case, I'm going to show you how all that works. And I'm going to show you the UI first, then we're going to get into the code because it'll hopefully help make that concrete. So this is the example.
Are you going to show the knowledge base, the scraping versus the docs so they have a visual?
Yeah. Well, yes, I'm going to show them the UI. If that's what you're asking.
Yeah.
Yep. So let's get into it. So we're going to just start with the agents. So there's my Ask Bob agent. Everything you see that I'm showing you, by the way, was stood up with code. So here's Ask Bob. You can see I was just have version 1. And then you have an alias. We're going to go into the alias. No, we're not going to go into the alias, sorry. We're going to go into the version. Okay. So this agent has two knowledge bases attached. There's an Ask Bob docs knowledge base, and there's an Ask Bob web knowledge base. I'll actually just show you these. Oh, actually I need to show you over here. So if we go look at the docs knowledge base, you'll see I can have one or more data sources connected to that knowledge base. It's got it's a vector store. Somewhere in here, it will tell you the embedding model. Oh no, it's back on the other one. So the data source is where it's pulling the data from. You have a lot of options with data sources. Let's actually talk about these. So the embedding models that AWS currently has are all geared around unstructured data, mostly. So PDFs, text files, things like that. They have some new sources that allow you to connect to, so they have a structured one that lets you connect to Redshift. That just barely came out. I have not played with it. It actually looks kind of cool. And then the other fun one is you can do a custom data source. And with a custom data source, you essentially are choosing your embedding model, and it's up to you to provide the documents to actually be indexed. The one benefit to using the custom is you can control indexing, and you don't have to do a sync. So let me show you what I mean by sync. So if I go look at this data source, so this guy is connected to, oh, those are the documents indexed. This guy's connected to an S3 bucket. So if I click the sync button, it's going to kick off a sync process. It's going to go through my S3 bucket and then index the data that it hasn't previously indexed. It's supposed to do a differential, but it's still going to go through all my data in S3. If your S3 bucket's really large, it's going to take a while. It's going to cost you some money in terms of, chunking through all that. So if you use a custom data source, you've got a little more control on what you're going to index, when you're going to index, and you can actually approach like real-time indexing, where you have an immediate chunk of data that you want to vectorize, shove into your vector database for long-term storage to use as a RAG source. You have that ability. So anyway, that's what custom's all about. So I'm going to show you the other one that we have. So the other knowledge base that we've got is this web one. So as Derek pointed out, our SEO is horrible and we are working on it. And so we wanted this, we wanted Bob to know who TrueMark was so he could answer questions about the company. So we created a web data source, and in here, we actually configured it to essentially scrape our website. So there's the source URL, and then I told it, if you have links that are going off site, don't follow them. And so I gave it a regex pattern essentially to maintain what it's going to index. And then same type of thing, I just went and clicked sync. You can control the concurrency on it. Actually does really good at scraping data. Just be aware, nothing is really good at scraping SPAs. So if your website's built with Angular and you guys aren't using server-side rendering, you're not going to get good results. It needs the actual content to go index. So other data sources that you guys might care about, ones that are pretty common. So you've got the web crawler that I showed you, S3. You've got Confluence, Salesforce, SharePoint. The Confluence one's actually super handy. It is in preview, so it means that they're still working out kinks with it. But you can connect it to essentially your Confluence server, and it'll give you a RAG source where you can go and ask the LLM questions about the content you have in your Confluence wiki. So, and then I haven't played with the Salesforce one. I don't know how much, like what type of data. I would imagine you can ask it financial data. But anyway, lots of stuff to play with. So that's knowledge bases. Again, knowledge bases are connected to agents. So, and then somebody was asking about prompt engineering. I don't have prompts built in using Bedrock prompts. I am doing prompts just like I showed you with system prompts, getting passed to the agent. That you have an entire prompt management system, all of which you can also do in code, so that you can build, complex prompts and be able to flip them in and out and change behaviors. And then flows is a way to orchestrate agents. So I'll give you a good example. So quite often you'll want to ask an LLM, let's say I've got a large language model that's really good at producing SQL statements. I've trained it, it's got a good RAG source. It can produce SQL statements specific to my database. I may ask it to go produce a SQL statement that I want to go execute to go and grab a specific kind of data. And I may want to orchestrate that in a flow where I have another large language model attached to an action that knows how to go and execute that and then answer questions from the data. So flows allow you to construct essentially flows of orchestration with multiple agents. So hopefully that makes sense. So, and then you've got playgrounds, all sorts of stuff. We can talk guardrails. I don't have any guardrail examples in here. Guardrails are essentially a way so you can protect the LLM from responding in ways that it shouldn't. You can do that somewhat with prompts. Guardrails are a little more hardcore. You also have the ability with flows, you can always use another large language model to actually protect and govern both the requests going in and the responses coming out of your main flow or large language model. So that's a pretty common practice as well. So any questions so far? I'm going to show you the code. Go for it.
Practical terms, what's the largest data source, you know, that you would say is a reasonable?
You can, so okay, so don't think in terms of data source. You could have a massive Redshift database, for example, that's a petabyte. I don't know if it'll allow you to a petabyte. It could be multiple terabytes, right? You could also have an S3 bucket with a petabyte of data in it.
But indexing, that's going to take forever.
Indexing is going to take a while, but you can do it. That's common. So what ends up happening is you've got so many tokens that are available for your large language model to use. That's why when they come out with these new models and everyone's boasting about, I can do 200 billion tokens, right? It's because that dictates how much of that search data you can take from your vector databases and shove into the large language model to ask it questions about. It also allows you to send immediately more data to it with your questions. So think of Copilot as a decent example. As you're coding, it's actually taking your files, using those as inputs. It needs to have a large amount of tokens for a large project. Because if you've ever noticed, that specific model is really good at giving you recommendations based off prior code you've written in the same project. So it needs a big range of token space to be able to go and index a lot of that data to answer. So in answer to your question, the data source size doesn't matter. The token count matters on your embedding models and your large language models. And it matters because if you have a really broad question and it has to go fetch data, and that data is really broad, you're going to end up just getting a subset of that data for it to go answer. Does that make sense? Okay. So I will also state that's why it's really important to test and experiment with your embedding models. You can tell it to get really fine-grained or coarse-grained in how it does that vectorization. And all of that tuning that you have with your large language model, all the tuning you have with that embedding model really affects how accurate those responses stuff are from the models. Does that answer your question? All right. Any other questions? Yeah, go for it.
The data source, like custom, do they, certain file types that they only?
Okay, so on the S3 side, yes, I think it's like PDFs, TXT files. You can have metadata files with each of those. I can't remember. There's like a small subset. With custom, the answer is no. So what ends up happening is you've got to choose an embedding model that fits your use case. So I'll give you a prime example. One of the projects I'm actually working on outside of this is we're indexing a very large set of code, and we need to be able to use that as a RAG source to a large language model. There are no current embedding models within Bedrock that are really good at understanding code semantics with TypeScript and Go. Okay, so I could go and I could use Titan as an embedding model and I could treat them all as text files, but I'm not going to get really good results because the model itself, the embedding model, doesn't understand code semantics. And so when it goes and vectorizes that database, it's going to be doing it based off, human language words, and how they relate, not how my variables relate and how my functions relate. Does that make sense? And so the model you choose is really what affects. So with custom, you can use anything you want. You're just passing documents to it. As long as the embedding model can take that data and vectorize it in a way that makes your search effective as a RAG source, then you're good to go. And I will also state you can do the same type of stuff outside of AWS, AWS Bedrock, still using Bedrock with like LangChain. So you could take a RAG source that is not even in AWS, and you could use LangChain with Bedrock to go and actually use that data as a data source for the large language model. So when stuff gets really complicated, AWS is improving stuff over time, but there are corner cases where knowledge bases just don't fit. So, but with custom, you can get quite far. And then obviously just the data store you use dictates kind of the size of the data. So if you use an OpenSearch serverless, if I recall correctly, a vector collection is capped at 1 terabyte. But if you use PG Vector, I mean, you can have a Postgres Aurora database that's massive. So, and then Pinecone's a SaaS offering, so they've got some other limits. So does that answer the question? Okay. Any other questions before we show code and hurt everyone's head? All right. Okay, so you guys saw Ask Bob work. So all of this is coded with AWS CDK. So I'll tell you why I like CDK. I also like Terraform, but I use them for different reasons. So AWS CDK is a way to code. You can actually code in multiple languages. At TrueMark, we standardize on TypeScript. I can get a DevOps engineer who knows Python to learn TypeScript pretty easy. And almost every software engineer has touched a front-end framework that uses TypeScript at some time. So it's not a far stretch. Getting a software engineer to learn Python when they're a .NET engineer can be super tricky. So TypeScript's what we've standardized on. Just realize you could actually do CDK with other languages. And then I like AWS CDK because it abstracts some of the weird CloudFormation stuff from you. You don't have to deal with it. And so we use that as infrastructure as code. It also tends to be far less verbose than doing Terraform if you're doing HCL. There's also a CDK-TF, which is a CDK version of Terraform, where you can actually do TypeScript with Terraform. But again, it's a little more verbose, and it still has the same nuances in regards to lifecycle stuff that Terraform's got. So anyway, so these examples are in CDK. So let me just walk you through the folders really quick. So CDK, that's obviously where my infrastructure code is. So we're going to start app. This is actually a Quick.js. That UI was rendered in Quick.js. So it just happens to be my favorite framework at the moment. Handlers just happens to be where I've got a couple lambdas, which we can get into. I am using GraphQL. So I'm actually using AWS AppSync, and that's how I get it so that essentially we're using WebSockets. But you can do this cool thing with subscriptions with AppSync. And so when you connect, it's actually getting a WebSocket, and then everyone's listening to the same WebSocket, and that's how you guys are sharing messages between one another. I'm actually going to convert this over. They have a new thing called, something events. It's going to slip my mind. Anyway, they've got another way to do WebSockets that abstracts even more. That's super nice. So we'll convert it over to that. But AppSync's actually quite cool. So, and then scripts just has a utility thing in it. So let's get into the CDK folder. So inside of the CDK folder, again, this is just a TypeScript app. I have this bin file. And the way CDK works is you're creating stacks. And a stack in CDK translates to a CloudFormation stack on the back end. So you can actually see in here, I am creating a data stack, a graph support stack, which honestly just spins up a certificate in US East 1. This is the Bedrock stack that I'm going to show you. This is actually where we're standing up that agent and the knowledge bases. And I'm standing up a vector database and all of that within that code. This is where I'm actually deploying AppSync. And then this is where I'm deploying the Quick City app. And then this happens to be an edge stack in Virginia. You'll see everything else is in Oregon. That's actually a CloudFront sitting in front of all of it. So anyway, we can get into this in more depth if you guys want, but let's show you the Bedrock stuff. So I'm going to go into Bedrock stack. We're going to go to the top. And feel free to interrupt me. So first things first, I actually go and grab a foundational model using the ID. So I was actually playing with Llama earlier today with this, so I happened to leave that in. This is what I was using before. If I wanted to switch models in this, I just comment one out, comment the other in, and now you're talking to Claude, and I go deploy it, right? So pretty easy. You'll also notice that here I'm actually using a constant variable, and over here I'm actually passing in text. So CDK doesn't have this model's so new, CDK doesn't have it yet in their library. And so this is how I'm bypassing that. So there's my foundational model. here's the embedding model I'm using. So I'm using Amazon Titan Embed Text V2. It does really good with PDFs, and it actually does quite well with the website indexing. Does not do good with code. So you'll notice that I am going to be telling it what the dimensions are. You have flexibility with these models to be able to tune them. This isn't doing much tuning. You just have to pass at least a dimensionality to it. These are just inputs from another stack. And then this right here is probably the most complicated stuff. So we're standing up an OpenSearch serverless collection. So that's what this is doing. This is where my vectorized data is going to be stored. And then I'm going to attach these to the knowledge base, and then I'm going to attach the data sources to the knowledge base. So in here, I have a security policy that dictates what can access that collection. I have a network policy that dictates what can access the collection. And then this is where I create a role that the knowledge base is going to use. And I allow that role to be able to do these things like invoke model, list foundational models, access S3 buckets, things like that. So this is going to be used for the docs knowledge base. And then I have another one for the web knowledge base, and then I glue it all together. So here's where I create an index for the docs knowledge base in my vector database. And here's where I create an index within that collection for the web knowledge base. I dictate some data access policy, which is for OpenSearch serverless again. And then here's where I actually create my knowledge base. So CDK is pretty interesting. CDKTF has the same concept. You have what they call L1 constructs, which are one-to-one with, in this case, CloudFormation. So everything that starts with CFN is a one-to-one with exactly what you would see in the CloudFormation documents if you were to do this in YAML, because you hate yourself, I don't know. So what AWS has done is, and we've done a lot of this too, we have some libraries published, we create L2 constructs that abstract this. This is just one that's not been abstracted. L2 constructs give you a lot of flexibility and essentially get you out of a lot of like permissions mess. It does a lot of stuff for you with these resources. So that's why this is a little large. But this is standing up that docs knowledge base. You can see that I'm telling it what vector database to use. I'm telling it what embedding model I'm using. I give it a name, tell it what role it's going to use. That role is how it talks to OpenSearch serverless and how it talks to the S3 bucket. And then this is my storage configuration. So this is essentially where I'm telling it the collection to go drop the data into. So there's my index name. And then I do the same thing. Oh, I guess that one was the web one. And then here's the data, the docs one, same type of thing. And then I attach the data sources. And here's where I create an agent. So at this point, I have created two data sources and an OpenSearch collection and two OpenSearch indexes. And I've glued that all together. So now I have two knowledge bases. So if you walk through the code, it'll make sense. I know this is a little fast. So now that I have these two knowledge bases, I want to be able to use them. So interestingly enough, in the console, I can actually go to one of these knowledge bases, and you can actually interface with the embedding model directly and ask it questions. It's basically an LLM that's just specialized. So let's actually do the web one because it's more fun. So it's actually going to go and search the vector database and hopefully come back with an okay response. It did not. Oh, because I was messing with Llama. If I flipped it back to Claude, it would work. So it's because it knows it's all hooked up. So anyway, this has to do with some LLMs allow different throughput models. So in any case, you can interact with embedding models. That's what I was trying to show you. So now that I've got all that hooked up, I'm going to create an agent. And that agent is going to glue that foundational model and my knowledge bases together. And then I can interact with that agent. Along with it, this is where you can do some instructions. So you can think of this as prompts, but these are not prompt engineering. So prompt engineering would be it's a little more involved. You can actually have user interactions with prompts where you want to go solicit information based off certain criteria, collect that information, and then use that as inputs. In any case, these are instructions. So I basically said, hey, you're an engineer and an AWS partner, friendly, helpful, you answer technical questions, your name is Bob. So those are the instructions that the LLM's been given, and it tries to work within those instructions. Here's where I connected the knowledge base. Yeah.
So you specified that friendly, helpful, you could say you're the jerk.
Oh yeah, we could totally do, we could do that, and I could deploy it if you want. Yeah, you can do all sorts of crazy stuff. Just realize a lot of the models that are produced by like Anthropic and Meta, you've seen this with the OpenAI's models too. They're pre-trained with some prompts built in, so they're not going to go and tell you like how to make napalm in theory, right? They shouldn't. And so just realize like all of those have been built in. If you were to develop your own model and you had access to all the data and you were going to go through and do your, $1 million training, you guys could produce a model that had no gates on it. So just realize this is a way for you to control some additional gates and give it some instructions, general instructions. Any-
Might not be a complete answer.
So
I mean,
I will.
helpful. You're a jerk and you're not helpful. Like
We could do that. We could do that. I'm actually curious what it'll do. Let's do it. We'll mess with it. All right, we'll see what it does. That'll be interesting. We'll deploy it right after this. Oh, need a comma. Okay, so attach the two knowledge bases. I'm just exporting some parameters. And then I create an alias. The alias is actually how you interface with the agent. So my alias name is Ask Bob. And then I'm just exporting parameters. That's the rest of this code. So that's the Bedrock piece of it. I've built everything in code. I can now do a CDK deploy, which I'll show you, and I can deploy it to my account. So before we go see how snarky it is, do you guys have questions? Because I know that was a lot and pretty fast. And I know probably most of you aren't familiar with AWS CDK. So happy to answer infrastructure as code questions, happy to answer Bedrock questions. Does anyone have anything?
Since you're on that topic, is the provider, the Terraform provider pretty good for Bedrock or?
Yeah, it's so the answer is yes. They stay on top of the APIs pretty well. Funny enough, it varies. So sometimes stuff's late getting into CloudFormation and Terraform will have it early. Sometimes it reverses. So it just depends. But yes, I mean, Terraform's just coding to AWS's APIs. So I've had too many awful experiences teaching .NET and Java developers HCL.
Yeah.
Does that make sense? So yeah, it's all there. So you could duplicate this in Terraform. It would be a lot longer. Like this, I don't know if I have any good examples in here. Like this stuff right here, like this is literally just adding a policy statement to a role. It's in Terraform, you're going to be building large policies and stuff like that to deal with permissions. With a lot of that level 2 constructs, like with lambdas, you can just do like, I can create an S3 bucket and I can do grant read permission and pass my Lambda function in the code to it, and it just does everything for me. And it does really fine-grained permissions. So it takes what I see most people do with Terraform code is you'll see a lot of wildcards in their permissions. And this essentially gets you more secure without having to actually code it yourself. We actually use a ton of Terraform internally, but we tend to do it for stuff that's shared infrastructure that I don't have software engineers playing with.
Yeah.
So yeah, so it just depends. That's how we delineate it. But yeah, everything you see here is all possible with the Terraform provider. So any other questions? Okay. All right, let's go deploy this thing and see what it does. So I'll show you a few CDK basics. So I'm just gonna make sure I've got my creds in here. I'm just gonna test to make sure I can actually list them. Okay, good, we're good. So first of all, I'm just gonna build the project to make sure everything's good to go and I didn't mess anything up. Okay, and then I'm gonna actually show you. So if you do a CDK LS, it's going to list out the stacks. So I actually have a script that I use to deploy all the stacks at once, which is this guy. However, I know that all we modified was the Bedrock stack. So I'm going to do a CDK if on the Bedrock stack. It will actually show me the differences. And then I'm going to show you something pipeline related after this that you guys might enjoy. So it'll take a minute. On my connection at home, it's quite fast. So we got some latency here. So this is actually the equivalent of doing a Terraform plan. So it's actually showing me what it's going to go change. So you can see that it's modifying the agent, and then it's deploying some custom resources that happen to be related to my indexes. Let's go deploy it. And while that's deploying, which should go pretty quick, I'm going to show you some funness. So at TrueMark, we've standardized on 4 CI/CD platforms. So we do GitHub workflows, we do Bitbucket pipelines, and crap, what was the other one? So we do code pipeline with AWS, and then do you remember the other one, Trent? What's the other CI/CD framework we use? No, was it GitLab? Yeah, it was GitLab. So anyway, we've got engineers that know all that. So I'm going to show you just for fun skis. I don't actually have it deployed, but if you guys were super curious how you'd automate it with code pipeline in code, I actually have a pipeline stack. This actually deploys a stage in a production environment of what I'm doing essentially down here manually into my account. And so I actually have it hooked up to the main branch. So if I actually commit and push to my main branch, it kicks this pipeline off automatically. And it essentially rolls the changes out in the proper order to the regions and the accounts that I asked for. So we actually do cross account stuff with this. So this actually runs in our DevOps account, deploys into our stage and our product AWS account, and it's touching both Oregon and Virginia. No, this is AWS code pipeline. So I didn't have to actually touch code pipeline at all. This is a CI/CD pipeline all in CDK code. So pretty cool. So if I didn't do this, like my next go-to would probably be GitHub workflows. But I like being able to build pipelines in TypeScript. There's some nuance to code pipeline, but this is pretty cool. You can also do neat things. Code pipeline has really good support to be able to do like canary deploys with lambdas and things like that. And then we have some apps where we're deploying multi-master into like 4 different regions and using Dynamo global tables. And we can actually stage those releases over the period of hours to be super safe. So anyway, cool stuff if you guys wanted to see that. So this has been deployed. Let's go see what it does. You guys asking questions? Let's see here. Oh, it actually, that actually wasn't a bad response. A little bit. So yeah, I mean, you can affect the behavior quite a bit. I would imagine, I don't know, like
I mean,
you might get,
it's only not helpful. It's like, it's not gonna not answer your question. It is a language model. Like it's.
yeah. See, it's actually answering reasonably well. I would imagine different models, you could probably get a different level of snarkiness out. So anyway, something to play with. So yeah, so that's it. Do you guys have questions? Also, if you guys want to try getting like those basic examples working on your laptop, I'll spend a little time after this. If you guys want to throw down Node, I'll show you how to get it working if you have an AWS account.
The generative AI initiatives they're gonna be working on that work.
for any particular project?
Yes.
Yeah. So the reason I'm bringing it up is AWS has a lot of incentives right now that they'll fuel fund your Gen AI projects. So if you have any interest in building something on AWS at work, reach out to us. We will connect you with your account manager. Well, Trent and I are super well connected within AWS. I'm a fairly recent separation from AWS, so I know a lot of funding programs. There's tasks to be given to partners. There's credits that can be put into your account, pay for the AWS services that you can use. The account managers have a lot of flexibility because they're really pushing this right now. So something to think about as you're trying to build stuff at work. You're at BYU, right? You're where?
Best notes.
Oh, that's it. Okay, so commercial and public sector work a little differently. So there's different incentives, but commercial has lots of incentives to do things.
So with Bedrock, since there's so many different AI models out there, I mean, what's the benefit of Bedrock versus some of the others?
The fact that you can, like, there is, other than the vector database and some of that stuff, there's very little infrastructure that you actually have to stand up to get RAG working. This almost becomes more of a application developer space than perhaps a DevOps space in a lot of ways. And then they're abstracting a lot of that agent stuff. Like, to work with agents in Bedrock is easier than working with agents with like LangChain, for example. It just depends. There are corner cases that absolutely do not work well in Bedrock. You can still use the large language models hosted in Bedrock, but sometimes, you know, and they actually, I'll show you this feature too. So and have not played with it. So at reInvent, they allow you now to import models. So that was their way kind of around some of that inflexibility. So the fact that they don't have any embedding models that really understand code well, I actually can now import an embedding model that does. And I can import a model that I train in SageMaker. I can take any one of these models and I can go train them in SageMaker or externally and then re-import them and then use them directly. So that's where you get the flexibility. Most of the limitations that I've found right now are in regards to those knowledge bases. But your way out of that is with that custom knowledge base. But you still got to bring like an embedding model. So if you use agents today, you can't use a RAG source that's not a knowledge base. Does that make sense? So if you really want to, let's say you really wanted to orchestrate something and leverage stuff, you know, that's in AWS and stuff that's not in AWS, you're probably going to go use LangChain and then kind of best of breed. So it just depends. But like this is you'll end up writing less code doing this, if that makes sense. So if this fits your use case, this is also pretty easy to break out of. Does that make sense? I don't know if did that answer your question?
So you don't have to, so you're calling them on the back end. Otherwise, if you're running your own, if you're running like in SageMaker, you got to go down the whole path. So you need to be running the model and then go query.
Yeah, prime example, a lot of people run models in like Kubernetes clusters and stuff like that, but they're running all the time.
Yeah.
So behind the scenes, they're actually taking your model and they're hibernating it and then bringing it back. So you don't know what the criteria is on when they do that, but like you're not charged for runtime, you're charged for calls.
It just makes more sense for enterprise. So like I've done HIPAA use cases on Bedrock.
Yeah, that's where the big thing is.
Use cases on Bedrock. So the easy button really is to go to OpenAI and just get some tokens and start playing with ChatGPT, but you have no control over what's happening to your data. So the other extreme that organizations are trying to do is host their own models, and they're running into power issues, they're running into compute issues. It's a lot of complexity. It's a lot of
hiring issues. Yeah.
With here, you're in an isolated account. You've got lots of different model access. You can import your own models, and you know it's all in your account. So you can do enterprise use cases.
Yeah, and you can guarantee that data doesn't leave. So if you're doing like medical research that's super sensitive, like you can do this and you can guarantee like it's not going anywhere outside of your AWS account.
So I do a lot of government work for the state, and they're really excited about AI. And a lot of them is just, you know, get reduced phone calls. But their fear, of course, is just opening up a general public large language model. Are they going to get the right answers?
Yeah, so there's an ISO framework that's been released that helps with some of the governance on that. And then to be honest, like it just comes down to really good testing.
Yeah.
So that guardrails is really important. And then, you know, your prompts and your instructions that you provide the models are really important. And then obviously don't vectorize data that you don't want to be part of an answer, right? You also have there's different ways to isolate data. So let's say I've got a set of customers and that customer needs to ask questions about their own data. I mean, you could do RAG sources, so essentially knowledge bases for each customer. You could logically separate it and just make sure you do it really well with prompts, and you can have another large language model guarantee that the output doesn't include, you know, any data from a customer ID that's not theirs. So it comes down to just modeling it really well.
Do something like this, right, where you're just actually using an agent directly with the agent. If you're worried about the additional, you're gonna get some additional functionality with the large language model. So you could drop it down to an agent where you're only querying the vectorized data.
Yeah, and guardrails are pretty decent. Like you can do a lot of protection with them.
Yeah, and I don't know if they're looking at that, but they have like lots of policy documents and stuff like that, so something like this is, that's why I was asking about the data sources, because they could. just-
Interestingly enough, a lot of those policy docs can be your data source
Yeah,
too.
so I think
So
that's what the safest with is just, well, we create these documents, we know they're accurate, this is what we train people to answer questions on. So let's just use that to be like.
yeah, the other thing,
Our agencies in the state using them right now, and this is a lot of the University of Utah's strategy for the responsible AI initiatives is using Bedrock to provide a lot to researchers and internal resources.
yeah. So just in terms of protection, you got guardrails. You can always use LLMs to protect LLMs, and it's all comes down to prompt engineering and your instructions that you pass it. And then obviously choosing a good foundational model that, you know, isn't going to be a jerk and snarky to you. I don't know. So any other questions?
Any experience using Google for text?
I do not. So actually, there's some Microsoft stuff that's on my list to play with as well, but I have not played with that. So any other questions? Sure.
Any IDE plugins that might well.
The answer is yes. And none of them are AWS's. So let me show you my IDE setup. All right, so I am a big IntelliJ fan. So I always code in IntelliJ products. I've got a bunch of engineers that use VS Code and whatnot. And then I mock them when they have problems. VS Code's great, but anyway, I get far more bandwidth out of this. So IntelliJ's got an AI assistant. I don't like it. So I have Copilot installed, and it works really, really well inside of IntelliJ. And then I have another plugin. So I always go get API accounts for all these. So let me show you the plugin that I use. So there's the Copilot one, and then where was it? Right here. It's called ChatGPT integration. There's a whole bunch of them. This one's by far been the best for me. And I will show you why. So between the two, so if I'm coding and say I want to do, so right there, that was from Copilot. Okay. Now let's say I have a problem with that. I don't know if it'll answer the question correctly. I can actually highlight text. I can go to add to context. And I'm actually have this currently hooked up to ChatGPT 4. I'll show you the config on it. And I just added just those lines, tokenize the data. So it's actually trying to answer questions just based off the context that I gave it, which is this guy. It's actually using API tokens. So I can show you that. But so when I am working in a code base and Copilot isn't prompting me and I'm a little lost, I can actually just right click on several files, add it to my context, and I can immediately start asking ChatGPT questions specifically about my code. And then on top of it, I can go and mess with, you can also bring your own model with this plugin. It's not like you're forced to use ChatGPT. So I could actually talk to Claude, Llama, whatever. And then what I wanted to show you was, oh, so this is my API key. So you just plop in the API key that you grab from wherever. And see if I can remember where it was. There is a place, and I just can never, oh, it's up at the top right here. So this is me telling it how I want to behave. So this was actually there by default. By default, it does this weird, I don't know, it responds in a really weird way. I can't remember what it was. Anyway, I did not like it. Here, we can actually, I wonder if it'll let me revert it. Yeah. So let's see here. English is a BIOS, best solution. Oh yeah, snarky and noir. So if I ask it now, it drove me nuts. I tried it for a while. So in any case, I have, it's really obnoxious. So I actually tell it, hey, let's see if I can find, follow these rules in each response, clear, concise. The lang, by the way, that's me injecting my project language into that. So it knows I'm doing TypeScript. And oh yeah, it kept giving me React stuff for Quick.js because Quick is a really new framework and I didn't have knowledge on it. And so I basically was telling it, just never give me any React responses because it was really ticking me off. So anyway, those are the two plugins I use. So I find them super effective. There's a bunch of other plugins for VS Code. Out of all the stuff I've played with on the code side, like it's hard to beat Copilot. It just works really well. So I have not played with Cursor, but I have heard about it. So it's actually on my list to play with. It's pretty good. Okay. So I get really good mileage out of Copilot. Honestly, like it's half my code. Like it's pretty good at predicting. One of the things I'm actually planning on doing is taking a model, feeding it a whole bunch of code that I have, because I have like specific styles I like to code in, and then seeing if I can use that as a RAG source, essentially, to feed an agent like this while I'm coding. So it should be interesting. Yeah. Any other questions? Okay. Well, there you go. All right.
Thank you.
Oh, it says we have no audio now. Hopefully that got fixed.
That was